I'm going to say Abadi. Okay. Let's get started.
Video call.
Who be that?
Daddy! Daddy did forget that.
Thank you, my email.
No, come. Do you understand? Yes. There's no more. It's not like that. And exactly how to communicate that all of the data you have and pick out research problems from there. So today we'll be discussing communicating computational research. Now, why we need to discuss this is um, it's a new kind of research. Until 20 years ago, the methods and approaches of research were confined to just three. This is some 20, 30 years old kind of research. Before now, we only had experimental researches, theoretical researches, and empirical researches. The computational kind of research is new. And in our space, it's some of us or some persons are still trying to get into that space where we can do computational research. And some of us will take a while before we will be able to publish a paper that is computational in nature. The reason is it defines the way we write research using questionnaire, the way we write research using field studies, the way you communicate or present a computational research has a distinct difference from what you maybe were taught in the university and all of that. It is why we need to have an overview, an expose of what it takes to do computational research. And by now you are aware that computational has to do with computers. So it has to be data. You need to have data somewhere, and you turn that data into valuable insights. It is this valuable insight that you want to communicate. And those plenty data you have would not make meaning to any of us if you are not able to turn it into a paper. So the act of taking a data and turning it into a useful insight that can be communicated to the larger scientific world or body of academics is what we call communicating computational research. So, slide number one, why it is important. If a grade 3 fell somewhere there and there was nobody to see when the tree fell and come out of the bush and tell us that iroko tree down the forest fell and great was the fall, I am not sure we would know how great that fall was. What does it mean? If all the data you have access to remains within your computer and you're unable to turn them into useful insight, you're able to derive research questions out of them, turn into research client's audience, if you begin to present plenty codes and plenty terms, they will not buy it. The paper may not even cross the decks. It will be decks rejected. And so today, in the few minutes we'll have, we want to show how, we want to tell you how we can turn our data to something very powerful. And sorry, I'm not going to slide so much. The slide is for you to study later. But go to slide 2, where we mentioned that this is basically a systematic approach of turning data to use paradigms, sample size formation towards engineering and data analysis. And that can be done with our with several tools. But I learned you are only doing Arrow at the moment. Okay. It can also be done with Python, it can be done with Julia. It can presently be done with AI. The avalanche of AI models can collect your data and turn them into useful insights in seconds if you know how to prompt them right. Because of course, the business of AI is being able to deliver the best of prompts. So, what do we do? What are the core differences, the core pillars of computational communication? The person who wants to review your research, whatever paper you come up with, was not there. He will not have access to the data. And so he or she wants to trust your process. For he or she to trust your process, you should be able to communicate how you got this data. What processes did this data go through? What we call pre-processing and future engineering. What processes did this data go through? You need to be able to communicate it or write it convincingly, so much that somebody in China, somebody in Pakistan can collect that process you described and reproduce the data. The concept of scientific communication or research communication is for reproducibility. Somebody should be able to, somewhere else where you cannot find the person, reproduce what exactly you said you've done. So there are 4 pillars of computational research communication. One is data provenance. Basically, how are we sure you actually got the data from the source you claim you got it? That is the first thing. In fact, anytime you put out a computational research, the first thing the person looking at the paper wants to look at is to rush down to the method section. And there he wants to see, where did this person get this data? Can I go there right away and see this data this person is talking about? So the first pillar of communicating computational research is data provenance and source quantification. Basically, what that means is your source of data. 2, the pipeline transparency. Yes, you got this data. What processes did the data undergo? Did you do some dimensional reduction? Did you do some feature engineering? How did you handle missing data and data duplicated data? What was the EDA, exploratory data analysis you did on the data? You must be able to communicate all of this. And of course, there are several techniques to do the same thing. You should also be able to validate why you use method A and discarded method B. When you're done with that, the 3rd pillar of communicating computational data is structural framing. Structural framing entails, okay, it is data, it is available, but does it solve a problem? Research is intended to solve world problems. How did you know it solves a problem? What are the literatures that support that this data, or the way you have framed the data, or the data you've singled out solves a particular world problem? That is what we refer to as structural framing. It must be supported by some literature, and finally, you should give us some elements of reproducibility. That is, tell us where the codes are kept. You're not going to add the codes to the paper. All of the data you add there, you won't put into the paper. You just give us a statistical analysis of the data you have. But we should be able to go to carry this your code that is stored in GitHub or in Zonedo or any of those places where data are stored. And you give us the code, that code will be added into the paper. And if we go to that repository, collect that code and run in our system, independent of you, we should be able to get the same results you got. If you're able to do those four things, then you have been able to communicate computational research. Now, the summary of what we'll be discussing today takes a step, or takes a number of steps. You retrieve data, use so data is not only numbers. Data can be words, can be emotions, and all of that. So the first business of any person who wants to communicate, who want to write a paper in computational data analysis, is to retrieve the data. Two, you study the data for patterns. Now the data would be plenty. Some of the data you would harvest out of the repository you're using maybe up to 10,000 data sets or data points. Some of the data you would, because I learned you're discussing big data. Big data, data is not big if it doesn't have up to 5,000 data points and above. So you need to study that data for trends, study data for patterns. As you look through the data, there would be a number of repeated patterns in the data. Once you are able to get that, the next step is to draw research questions from the data. Now, unlike what you have been used to, where you have a topic, or maybe you search literature and find a gap, and from the gap you get a research question and get a research topic. The reverse is the case in computational kind of research. In computational research, you don't go searching for a gap on Google Scholar or Semantic Scholar. You come to the data and look through the data. When you have looked through the data and found a pattern, you will now on your own from the data formulate a research question. From the research question, you would now turn this question into research topics. Let's say we're looking at Trump's tweets during his first tenure. And as you look through the different tweets, you saw places where he continually tweeted violence or use of violent words and all of that. And you can point, oh, here there was violence, here there was violence, there was violence. The next business would be, what research question can this answer? Is it possible that Trump's tweets instigated the White House breach? Because I think in Trump's first tenure, there was a White House breach. Is it possible that his tweets led to the White House breach? These are questions that, by just looking at the words or the different tweets he made, and about that time, you could find a pattern. From this pattern, you get a research question. From the question, you draw out a topic. Your topic could be, of course, topic had framing, but we're not yet there, you're not there today. Your topic could be a sentimental analysis of Trump's tweets. Your topic could be a Scopus review of Trump's tweets, but you draw a research topic from the data available. You do not come with a topic to meet the data. That's not that part, because that is one of the mistakes we do because of our background of the types of research we have been used to. In the other type of research, we have a topic and we now go to find data. No, here we have a data, we need to find a topic. And so you, from the data, get a topic. When you have the topic, you accept that topic may not fly. That topic, remember that we are trying to get delivered from point of view. So your research topic would need to be tested against what serious journals accept. I believe that part of your aim here is to publish in Scopus Index journals and Scopus Web of Science and all of those big ones. They do not just take any kind of research. Your research must have 3 conditions: NOC, novelty, originality, currency. NOC. The topic must cross the bar of NOC for a Scopus Index journal to want to take it. So whatever topic you are framed, you will need to go and test it for NOC. Is this topic novel? That is, novelty is it brings something new to the discourse. Is this topic original? It's not someone's Scopus work or you copied it from the US and only changed the location. Yes, most of the research we have in Africa, it's been done somewhere before. The only thing we're contributing to the topic is a case study of Nigeria. Yes. And it could be novel if we actually do it right, just that we don't do it right. We just copy the same method and all of that and only change event that was source. Okay, so you have originality, then you have currency, very important. A Scopus Index journal will not publish your paper if it is not the subject of discourse of the last 5 years. A Scopus Index journal will not publish your paper if it is not current. Currency is what the legal literature, the legal body of researchers are discussing in the last 5 years. So you must test this topic or this topic you have gotten for these 3 qualities. If you have 7.5 over 10 for these 3 conditions, then you have a research topic. And I know you're wondering, where will I test it for 7.5 over 10? When there was no AI models, we used to get to our professors. This is the topic I have. Can you help me check if it is novel? The professor will go to Google Scholar and put the topic and or put keywords, not the whole topic, and some topics or some works that I've done, things similar will pop up. Then he would carefully check for us if somebody has exactly done what we're doing. But we are now in an advanced day. We now have AI models. 2 AI models have stand out in their ability to check for NOC for you, ChatGPT and Cloud. So whatever topic you have gotten, take the ChatGPT and Cloud. Why ChatGPT? If you're on the paid version of ChatGPT, you're connected to online 247. The version is not like the free version where it hallucinates. The paid version allows you to access the 5.6 memory of ChatGPT. 5.6 memory of ChatGPT is the current memory of ChatGPT, and it gets into the internet space in real time. It could get to Scopus, Web of Science, any database, and tell you exactly if this topic has been tried before. I wish I had time how this one would have been very practical. I was taking to ChatGPT and share to do that. The next person that can, next model that can do that is Cloud. Cloud, I think it is less than 1 year old. So it's still very much competing with all of what ChatGPT is doing, and it is built in Julia. Julia is a lot more very serious programming language than Python that ChatGPT is built on. And so it gives you some very current information. So put your topic into any of these models and ask you to assess it for currency, novelty, and originality. If the two of them gives you 7.5 over 10 overall, then you have a topic that will not be turned down by any serious outlets. Now, of course, you are aware that some of our journals not even check that. That's why we are pushing for get to that space. Let us focus to Web of Science, where you have persons who want to improve you, want to be sure that whatever you're putting out there is contributing something substantial to knowledge. So when you are done, or when you have a topic, it will now be time to check if that topic is supported in literature. You do not have a topic yet until there are at least 20 papers that support that topic. I'm aware that you'll be presenting concept notes. Yes, in your concept notes, the reviewers will be looking out for where are the 20 papers for this topic. If you don't have that, you don't have the topic yet, you are still late.
That support different aspects of the topic. Might not be the core.
The 20 papers you're looking for would support MPSA. Method, problem, solution, application, MSA, MPSA. The method or the 20 papers you're looking for that will support your topic will support the method direction you're taking, will support the problem within the topic, will support the solution you're bringing, and support the application. Method, problem, solution, application, framework.
So does this 20 papers you're talking about, does it also concern concept notes and proposals that have limited number of pages?
Yes. You must cite those 20 papers when you're writing your concept notes. Now, I also need to mention that for computational papers, frame your topic in the MSA. For computational topic of paper, frame your topic in the MSA. There are plenty of topic formation. There is Python, there is Pure, there is Spider, there is cards. Frame your topic in the method, problem, solution, application framework. Once a reviewer, editor-in-chief, sees a topic that is framed in the MSA framework, they already know what the topic is about. It is most likely going to scale test rejection, because the worst that can happen to you is your paper to be test rejected. When the paper is test rejected, they don't tell you why it was rejected. They don't say, sorry, we are sorry, we could not proceed or process. Yeah. But if your paper gets a peer review, the peer reviewer will tell you exactly why this paper was rejected, which will form your basis for revision. The editor-in-chief doesn't have that time. Just tells you that, sorry, we could not be more positive. So you want to look for a way to get your paper past test review or test rejection. And so frame your topic in the method, problem, solution, application, framework. Now the method tells us the method they're going to use in that paper. I am doing a XBoost, whatever. The problem that your topic is solving, the solution you are bringing, and where this your solution will be applied. That's what we call the MSA framework. Now, when you're finding your 20 papers that would support whatever you're writing, those 20 papers, some of them must support the method, some of them must support the problem, some must support the solution you're bringing, and some must support the application. About 3 of the papers should be seminar work. Seminar, a work that establishes a new field, is called a seminar work. And 2 of them should be reviews. Systematic review, scoping review, narrative reviews. So you have 20 papers broken in that direction. How do you get these 20 papers? that will support your work. Two ways. The traditional way, go to Google Scholar, put the keywords of your topic with the boolean, and it will give you all the papers that have discussed such things before now. Or you use a new addition to Google Scholar. Like I said, I really wish this could be a practical session. Please,
Yeah, we can.
Come here. This is the system you're using. Please
No,
go to
this
Google
one.
Scholar. Go to Google Scholar. As you turn on Google Scholar, you will see something new to Google Scholar that can help you find literature. Yes, once your Google Scholar prompts you on something, that thing is 3 months old or 4 months old. You see Scholar Labs. Scholar Labs. Click on it. It gives you a prompt box, and it takes only a research question. So if you have a research question, put it there, and that guy will give you 70 papers that support the research question.
So we have
One
it,
click.
we have it on the screen.
Yes.
Please take that again, sir.
Okay. That model, that research labs, only takes research questions. It wouldn't take a topic. So if you have a topic, turn the topic to a question. You have a topic, turn the topic to a question, and you put it on that prompt box.
And it gives papers.
Yes. To give you papers that are very real because it is tied into the Google ecosystem. This is not a GPT that hallucinates. This is direct Google Scholar.
Do you want to get any output? Yeah. Does anybody have a search question that we can try? Okay.
70. Okay, we don't have any, just type my new discovery there, it will give you. Stokes induced stack effect. Stokes induced stack effect. Stokes induced stack effect. No, stack is STA not CK.
Okay.
The Stokes is 1O. The Stokes is 1O.
Yeah.
Okay. Okay, so you make the equation. Is Stokes induced stack effect? Is Stokes induced stack effect?
Okay.
Stokes induced stack effect a quantum effect? Enter. All the papers that have discussed Stokes induced stack effect will be out in seconds.
Thank you.
So you would have, if it is a Stokes induced stack effect is a new effect, so you just have 2 or 3 papers that have discussed it.
10 relevant results.
Yes.
For the same thing or for a different.
Let's see how you type
You
it.
need to move to the next page.
No, the result is even on the other side. The result
Go down and find more and more and more. If it's a wide discussion, you can get up to 75 papers in one click.
I got 20. I can click on more results. You can click on more results. And I found 20. You can keep going down, click on more results. I do this one, I've never clicked on labs. I'm so embarrassed.
But you do it's about 3 or 4 months old.
Yeah.
Almost all can nine. So you can see that.
So I'm going back to it. Yes.
When you mentioned that the currency, for the ones in academia that always almost always anchors our studies on theories. Does the currency count? We usually have theories, 1978, do they count?
No,
So we don't bring them in.
you don't bring currency, it's not about the theory. That's the theory discussed in method center.
Yes.
No.
Okay.
Theories are
But I think that to that extent, when it comes to theories also, theories are also stagnant. So there are new dimensions, and some, let's say, I mean, because maybe you're dealing with maths and there's a new dimension. There are even some dimension, maybe let's say you're dealing with, maybe is what I use more, maybe ecology. There could be a new dimension that speaks to your specific issue. So that currency still count, but you may trace to the original maths, but you still bring this.
So do we cite the original count?
Yes.
If you like maths.
Yes. I have a paper here that cited a paper of 1929.
Yeah.
That's a seminal work. That's the first paper that discussed one of diamonds.
And classics are really foundation.
Yes.
Yes, it is.
Yes, because they're theories.
It is the paper that introduced what method I'm trying to push forward. So seminal works do not depend on currency.
Okay. Okay.
Seminal.
Seminar, yeah.
Seminar.
But maybe just to add like this angle finally I'm talking around. On the ground of seminar works, classics. I like the fact that you're saying you bring those in, and that's important because that's where I also have problem. Sometimes some persons overpush this issue of currency on certain issues when some of the works you're seeing that are just charts, they're not giving you the real deal. So I believe that it should be balanced. But the place of suppose is that the issue of you are in the same constituency. Some people will tell you it's classic, they want to be classic. Some persons also want to push the issue of currency, so that and currency is losing the proper value. And you're holding on classic, you're losing the modern trend.
I think in our space we agreed on something.
Okay.
My university is also pushing on use only the last 10 years.
Yeah.
The part of the last 10 years.
Yeah.
And some of political issues we are not formulated 10 years ago, they were formulated into 50.
Yeah.
And how do we bring that into this situation that we only want 10 papers in the last 10 years? So we agree that if a paper is beyond 10 years, mention it on the author, you have citing.
Oh. Wow.
Similar to the work of Karl Marx.
So that's by Godsky, no 1978.
No.
Just say that.
According to the work of Karl Marx, it is a known
authority.
Yes, a known authority.
And dealing with guarantee.
No, that's great ambiguity. What is great ambiguity?
I think we have also conquered the plagiarism issue now.
Yeah, there are a lot of way around.
No, not even the AI method. There is a new body of learning that says paraphrasing should be outdated.
Yeah, that's
so what do we do?
more like
synthesis.
Yeah, synthesis.
Read it and bring out the meaning in it.
Read 5, 6, 7, 8 words. Give us a summary of what they said. Without quoting any of them.
Okay.
Like you do somebody writing in SS3, right? You do somebody writing rules.
Yes.
You cannot quote anything verbatim. So read and understand and write it in your own words.
That way you don't cite anyone.
Yeah, you cite them in group, but you're not plagiarizing.
Oh, yeah.
Yeah. In paraphrasing, you copy the person's work and change the words. Here, you're not copying any of those 5 persons' work. You are basically, you understand what the 5 of them said. You agree on the point. You say, several studies have agreed that X, Y, Z affects Z.
Yes.
And you put the citation.
So what do you call that?
Literature synthesis. So we are now at the age of literature synthesis. We no longer paraphrase. That way we have overcome plagiarism, since you did not quote anybody or did not copy any person's word verbatim.
No, it's not true. It's not true.
And
What is it?
something would highlight it or not, since you didn't copy any person's word. Now, how we're able to achieve that is another product from Google called the Google Notebook LM.
Yeah.
The Google Notebook LM allows you to collect plenty literature and draw up a matrix of literature, what I call the strip table. What I call the strip table in text, it is called literature matrix. The strip table allows you to pick up several literatures and collect 5 things from them. What they did, how they did it, what they found, what they concluded, the limitation. What they did, how they did it, what they found, what they concluded, their limitation. And lastly, how they support your current study. What they did, what they found, or what they did, how they did it, what they found, what they concluded. You will find what they did in the abstract. How they did it, you'll find it in the method. What they found, you'll find it in the discussion. What they concluded, you'll find it in the findings or the conclusions. Okay, so that is that on finding literature. When you've gotten literature, about 20 of them, and they support the problem you're trying to solve, they support your method direction, they support the solution you bring, and they support the thesis. Somewhere there, before you leave, you will find 5 statements. These are not convention, but this is how I have been able to write computational papers, and they have scaled multiple peer review. So when you got those, go back to that the previous slide. Yes, when you got in those questions, somewhere there you will find 5 statements. 5 statements. You'll find 1. You craft the problem statement. 2. You craft the thesis statement. 3. You will craft the method statement. 4. You craft the novelty statement. Questions. When you, at the point where you find literature, before you move to the next step, that's interlude, that's between. At any time you found question or papers that support your topic, you need to craft statements there. The first statement you need to craft is problem statement. It is the problem I see. I found that this XYZ study have been done, but they have not been able to do this one. 2, you find thesis statement. For this problem I see, this is the solution I bring. Thesis statement. 3, you find method statement. You write the method statement. For this problem I see and solution I bring, this is how I will be bringing the solution. I would collect data from this bank. I would do future engineering for this data, and I would write a Python code on how to code the machine learning model. I would run expos for a random forest, and I would
Hello, can anyone hear me?
Yeah, who is speaking? Emmanuel.
Yes, Emmanuel, yes. Please, I didn't get the second statement you mentioned. Can you please mention it again?
Statement.
Thesis.
Yes.
Okay. Thank you, sir.
So the first statement is problem statement. Then you have thesis statement. Then you have method statement. Then you have gap statement. Gap statement. This is the gap that remains after decades of research, after several advances. This is the gap that remains. Gap statement. Then you have the novelty statement. This is the new thing I am bringing. When you have those 5 statements, you can now move to report the method section. But before you move to report the method section, you need to find a seed paper. Seed paper. Sorry. Before you move here, as you get to this point, you need to find a seed paper. A seed paper is a paper that reports a similar method that you intend to use. You're not the first person to do XBoost, or you're not the first person to use When you have that, it will now be time to report your method section. In computational paper, you write the method section first. You write the method section first. When you're done with the method section, you do your data analysis. It is when you're sure that the data analysis is confirmed, it can produce you a Python plot, it could give you a Boolean plot, it could give you a random reduction, it could give you an ROC. It is when you are sure that all those plots are somewhere, you will now go to write your introduction. If those plots are not somewhere, you're not sure that research proceeding. So you write the method section. Method section, my next slide, please, has 5 parts. So what I have there is the cycle of writing a computational paper. You begin from retrieve the data, from the data, find patterns, from the patterns, get a research question, from research questions, get a research topic. From research topic, you get literature that support the topic, and you get your statements and you report the method. Now, this is the 5 parts you must have in the method section of a computational paper. 2.1, data retrieval and mining. Where did you get this data from? How are we sure that that data is in that site? You must give us a link to the site. You must give us the day you retrieved it. I think I will have some examples down. Data retrieval and mining. Here's where you do data provenance. That this data is actually in that site, you tell us it's there. 2, once you have retrieved the data, you tell us that this data was collected from X, Y, Z. Remember, you write the method section in past tense. Okay, this data was collected from X, Y, Z, and X, Y, Z. Then you discuss with us the data cleaning you did with the data. This data, when it was collected, was not in a table. It was scattered, it was in words. I was the one who arranged it in tables. In data analysis, that is the normal market data analysis. Data cleaning is the collection of data and putting them into a table. That's the same thing here. So you collect them, put them into a table, find, tell us which of them is the X variable, the Y variable. If you're going to do a supervised machine learning, that's what you're going to do. That is that are able to build a model that can predict when the next crime will happen. Because the model is on social media, as they monitor conversation around youths and young persons in social media, they can tell you that from what we have heard, this place is where the next crime will happen. And it has shown some 70% degree of accuracy. So that's where machine learning, or what's called computational modeling, is going to. There's also what they call natural language processing. Yeah, it just those of you in linguistics and communication, that's where you try. You can write models that can predict the next choice of words, can even create new words. Yes. You can create new words. It was applied in what's this movie? I forgot the movie that created a new Game of Thrones. Game of Thrones created new words or new language, not even words. But somebody from linguistics was employed to create a whole new language that has never existed in the world before, using machine learning. And natural language processing. So that's where computational discussions are running towards. So you tell us what cleaning you've done, then you tell us what future engineering. Future engineering includes such things like identifying duplicates, outliers, missing data, how you handle your missing data, what exploratory data analysis did you do on the data? Because once you pick a data, you must first do an EDA. The EDA tells you if that data will progress further. Is there a meaning in this data? It's what is the anchor saying? What is what the data count saying? You must do all of that in the data and tell us how you did it before you progress. Then you now be time to discuss data analysis and model execution. What analysis did you do on this data? What did you write a Python code? Did you write an arrow code? What dependencies did you use? How do you treat the API? And all of those things you did. Where is your, that will move us to the next. Where is your algorithm stored? How did you execute? How did you execute the data you have? Then you tell us where it's stored. I have stored this in GitHub. I've stored this in any model you're going to store it and all of that. So 5 parts. This time you're going to present us the method section of a computational paper. These are facts we're going to see. 2.1, 2.2, 2.3, 2.4, 2.5. Next slide, please. So, what do you report in the data retrieval and mining section? How do you write it? I'll give you an example. Basically, here I want to discuss your source, how you assess the data and the parameters, how you define your boundary conditions. You'll see an example there. Data was harvested from the Redis platform via the push shift API and the official Reddit academic API became the retrieval targeted posts and comments across 3 climatic focus, all of that. Past tense, choice of words. That's why I gave that example. Right in past tense and the choice of words. Yes, there is English for research writing. Different from English to speak. So you need to understand and learn the English for research writing. Okay. And notice that there is no citation. It's intentional. The only thing you cite here is a link to the source. There's no citation to literature because here you're telling us this is where I got the data from. You only will cite here if you have gotten the data from another paper. You only recite here if you have gotten the data from another paper. Next slide, please. So we have data cleaning and pre-processing. Here you tell us the number of data points you have, why you have that number of data points, how you handle missing values and then structural integrity, how you handle tokenization and normalization and feature scaling. The data was about 1,000 or 10,000. I only use 5,000. This is why I use 5,000. Don't use all of the data. Some data does not make meaning. This is why I discarded them. That's why you report that kind of thing. Data cleaning, duplicated data, and all of that. You tell us why you dropped some of the data. Remember that you have told us where the data was in 2.1. The person may go to that site and see that the data was about 10,000. For your analysis, you only use 5,000. If you don't report it, the paper will discard it. You're not truthful. The source had 10,000. I only use 5,000 because of XYZ. Okay, data cleaning and purpose. Go to the next slide, please. Feature collection and multicollineal filtering. Prior to model training, this was what I did with the data. Feature selection was performed to eliminate redundant variables, feature displacing, all of that. Any of the things you did with that data, you're going to mention it here, including your EDA, including how you identify which should be X variable and which should be Y variable, and all of that. Go to the next slide, please. Next. Okay, with analysis and model. No, go back. I'll spend some time here. No, data analysis and model storage. No. Yes, model execution. Okay, I'll spend some time there. Why I'll spend some time is because unlike the kind of research you have been used to, the kind of data analysis we do in a computational research is distinct and different. I know that in social sciences, you're very used to bar charts, pie charts, line graph. You're always measuring how, yes, relationship, line graph, relations, how independent variable affected dependent variable with a moderating variable, and all of that. We don't do that in computational whatsoever. We go step further. So we build ROCs. ROCs. Not in the slides, so I'll just tell you a few things, a few kind of charts that we will do here. One, we drew heat maps. Heat maps, kinds of charts or kinds of analysis you do in computational research. One, heat maps. Two, dimensionality reduction plots. Dimensionality reduction plots. You can only do that one in Arrow and Amos. Have you planned out the Amos?
Also in Python.
Yes.
Yeah.
Dimensionality reduction plots. RODAs is what they are called, or DROAs. Two, or whatsoever number, ROC calls. ROC calls. ROC means receiver operating characteristics. You do ROC calls. Now, the area under an ROC curve is very important for us. The area under an ROC curve. If the area under an ROC curve gives you 1, then your prediction was very accurate. If you give 0.5, you have a random prediction. So when you draw an ROC curve, your interpretation is on the area under the curve. Then you do Boolean plots. Boolean plots. A Boolean plot is a probability density plot built on a chi-square normal distribution. BIO. Yes. Boolean plot is a probability density plot. It is.
Sorry, sir. Can you mention this plot again? I didn't really get the name.
One heat maps.
No, this one you are talking about something violinist.
Violin. The normal musical instrument. The violin plot.
Okay, violin. Okay.
Yeah, the violin. Yes. A violin plot is a probability density plot built on a normal distribution and z-scores. Those of you in social science are used to z-scores and student tables. Word map. If you're doing a scope analysis, word map. Word map. I use it online. I can show you what the word map looks like. Word map.
That's another.
Yes, another plot.
Word map.
Yes. Just like word map, you see word map. No, like 20 words.
Word map or
Word.
there's another name.
Word.
There's another name for it.
Just like word map on on psychology, you see a word map.
Word map or word cloud.
Yes. In psychology, on your field, you see a word map display on the images. Go to images. That word map. That's word map market.
Yes.
In social sciences, it's a plot.
Yes.
The plot you do when you do a scope of analysis or a word analysis or like a drum tweet, you need to go to the word map. Let's interpret it. Let's pull it one. Let's interpret
The
it.
bigger the word, the more frequent it is.
Okay. What's it called? What's that in printing? The intensity, where the colors are more intense, shows you that this word was used more.
More.
That's interpretation. So if you put it in your paper, you must explain it that way. That the color intensity, if you look at that, on the MAR, there are more, the words on the MAR end are more intense than the word on the TING end. The words on that end are more used, are more frequent. So offer, management plan, the price, product sales, target are more used than success analysis, development strategy, and all of that. That is how you report or interpret a word map or word cloud.
Or word cloud.
It is a visual you must use when you are discussing Scopus analysis or Scopus content analysis. Then network graphs. Network graphs. Network graphs. I pull it out, let's see how it looks. So I'll also look at how we interpret it. Network graphs. There you go. Looking so much like an SEM. Remember SEM? Social equation modeling.
That's what it is. That is it. Is it? And it is. It's same thing.
Okay, and you have all of that. The bigger, in the first one, the bigger, the more frequent. The thicker, the more frequent. In the first one, the bigger, the more frequent.
And they are pointing towards
Yes,
those who know.
they are pointing towards or the data point you were interested in, or you plotted, or you did a network for. In the second graph, the thicker, the ones with blue are more frequent than the ones in yellow.
Yes.
Yes.
So there will be a legend to interpret each of the color. The color could be a tweet. Maybe yellow could be a tweet on COVID-19. The other one could be a tweet on politics.
Okay, this is not part of the slide as I draw to a close. Types of research you can do in kinds of very impactful researches you can do. One, you could see. I don't know to what extent you will learn Arrow in the course of these 2 weeks, but if you learn Arrow up to machine learning, I would advise that you push towards an NLP on a sentiment analysis on Twitter.
Analysis.
Twitter. Sentiment analysis on Twitter. Two, spatial temporal analysis. Spatial temporal analysis. From data you have, you can do a spatial temporal analysis.
It's spatial.
Spatial, yes. There is one data you have here that discusses people's emotion when they hear fake news across different countries. That is a prime data for spatial temporal analysis. How people respond to fake news across the globe. Like the COVID-19 case. Like the Ebola case. COVID-19 was a lot more.
Ebola killed people, sir.
The whole salt thing was captured by Wikipedia. So you could turn that to a special temporal analysis that will give you very valuable insights and produce several papers. Number three, social network analysis. Social network analysis. computational trafficking. Computational trafficking is also analysis you can do with data I see that you have. Okay, I want to know what area of the world is having more child trafficking or women trafficking. Women trafficking. They have it. Okay. Yes. It's not common, like the data shows that it's not common in West Africa, it's common in East and North Africa. It's common in the Schengen nations. Very common in the environment. The data shows that almost every Schengen nation is trafficking women.
So when they convince men that there are jobs and they trek across the country, nobody sees.
No, there's not an abolition.
They don't call it trafficking.
No. Any man who attempts to cross the desert go by evolution is not the truth.
That's even illegal migrant.
So it's not trafficking.
Because you're going to draw an
There's
illegal
a distinction between trafficking and that.
For myself, if you want to be
I have a little
So you think there are no men that are deceived?
No.
For us?
No. It's difficult to find. The few trafficking cases we had in Nigeria, they think they have a job waiting for them overseas. Once you, the fact that they give the job from here.
just come over.
Yes. And once you got there, they collected your passport and you had no freedom to go outside the country. You lost off.
Forced labor.
And you can't tell you that the amount they used to bring you down here, and you say it's enough of fish paying the amount. In Akwa Ibom 2-3 years ago, some of our young men were trafficked to what's this African country, Ethiopia, and locked up. And I know that in the local government, some 10-12 young men were carried there. They said they were doing tiling work. So that the tiling work they were paying $10 per hour. The guys sold land and traveled to Ethiopia. Once they got there, they locked them up into the factory. And so that the money they used to bring you here is like 10 million. When you work the money, you go back. How we got to know about call his parents that please, so this is the situation I am facing. They need 10 million. The person will send 10 million before he was allowed to come back.
I know 3 students in my department that were trafficked. In the sense, they were told that they had jobs for them in Ghana. Yes. They entered night bus. They left for Ghana.
Any period outside Nigeria that told you.
They already knew how to repair phones, so they told them they had jobs for them. Sent them transport, paid for their ECOWAS passports and everything. They went there and turned them into something else. Only one boy came back.
Okay, to the extent of what we are saying, I think we almost reached here yesterday.
Yes.
But, so, where I agree with you, we live in a world that is hypocritical, and that's where we came to that conclusion that men are endangered species. So if there's conflict in this place, I want to call attention. Don't say men are produced to die.
Hey.
But when you say women are killed, children are killed, attention comes. So a boy child is kidnapped, the world is silent. Men are meant to suffer. Let's say they kidnap girls. As though they don't, as though we're not saying that this trafficking doesn't happen. But the issue is that even the data have been focused on women.
Yes.
Yes. How we're discussing yesterday.
So now you're dealing with big data. You may not have those data. No,
Those small fraction of men being trafficked.
Yeah, but that opens up maybe an academic opportunity to now
begin to gather such data.
let's build towards this other end. That's my
You need to produce data.
Yes.
So in 5-10 years, there will be enough data for others to mine.
I agree.
Okay, as we bring this to a close, how AI can help all of these things. Yeah, I have to ask.
You said 5.
Okay. Yeah, I mentioned 5 now. NLP, facial temporal analysis, social network analysis. You think of that point?
Yeah.
Computational trafficking.
Then computational linguistics. Computational linguistics. If I have somebody in marketing and branding there, there is now marketing. There is now computational marketing. Yes. Okay, let me give you an insight. Have you been thinking about something and suddenly you went to Facebook and saw something? No, it's not with that. Or you went and clicked one church this thing, they'll bring 20 church programs for you. They are competing you, they are competing your food. That once you click one church, it means that you like church, they will bring 20 more.
No, even on Truecaller.
Yeah. Or you click on Temu. All the Temu products would advertise to you.
Also use our music apps like Spotify.
Yes.
Any music you playing,
That
type of
I recommend that system.
Or somebody called you, 3 minutes later, the person is looking for is suggested as a friend to you on Facebook.
Yes, you are there.
That's computational marketing. They gather data and suggest, oh, if you bought cigar, most likely they drink alcohol, see alcohol every.
And then people that like POS, they like it a lot.
It's not rich, it is somebody sitting down to check what are your likes. Let me suggest them to you. And they now prospect, they forecast. Since they buy cigar, most likely when they drink alcohol, they not suggest alcohol to you. If you buy the alcohol, they not maybe next time they will suggest cocaine. It is your trend. If you bought blender from online, from Temu, what comes out of blender?
Or if you want additional,
Yes. I bought last time from Facebook, this laptop stand. They have given me 5 different types. Different types. Yeah, I have to buy new. So that's somebody doing computational marketing with you. They collect data on what you like, what are your preferences, what are your choices, and suggest, prospect. They are not in an office.
It's just like you're not conscious about what's happening. Some persons are not conscious about.
Yes, so somehow you have. You have.
Yes. We don't need.
Yes, when you see cookies, accept cookies. All cookies are those are the consents.
You can govern. I don't know if we can, but how do we govern? It can lead to
Litigations.
like pressure.
Okay.
Like people that keep looking up conspiracy theories, the world is ending tomorrow. That's what they keep seeing. That's what I know so much. That's what they keep seeing. You will tell somebody to do this, they say, you don't know that the world is ending tomorrow. 666 is here, Illuminati is there. What do you do about such things?
In the country at the moment, we do not have a governance framework for social media. Not AI is too fast. Social media, we do not have what's the name? Copyright protection and all of that. Not. We are AI is Facebook is marketing us like no man business. In some places, it is controlled.
Yes.
In the UK now, for example, there is now a control on you cannot to you cannot sign up.
Yes. And then the point that
you will have your picture. The UK now built an algorithm into Facebook. You will show your picture. Your picture can tell something about you. Okay,
no, but even within those systems, you have a data management system, and beyond you wanting to do what you do, is the reality that whether Facebook or any of these organizations, they also held responsible. I don't agree. I did not agree with the Nigerian government, but Nigerian government could not hold Twitter responsible when they said they were banning Twitter. But in these systems, they hold this. So even Facebook will do a due diligence not to grant you that admission or permission.
But the opinion graphic
I'm not
We don't have a framework. We don't have a social media law. Apart from this, what's it called, defamation, that is the only law we have. We don't have how much is social media, yes, how much is social media exploiting us. We don't have that kind of framework.
I'm
Because
more
if
happy
you
on
are
them WhatsApp
pictures
than
in other clients and you're not
and I'm more happy on LinkedIn than Facebook.
You should just continue feeding it with things. One day to balance the Bible.
It is why we're learning what we're learning so that we can begin to change the narrative. Now, like I said, as I was going towards the close of what I will discuss today, I guess you know that the papers you send out there may not be immediately accepted. Have you prepared your mind for that level of rejection? No, a brutal rejection.
But it's a learning process.
No, it's a learning process when the person said your work, no,
Okay,
your work is. There's a review I had last week that said he will report me to my VC. They are recommending that I should be reported to my VC for using AI to write and for using word that not exist.
International.
Scopus. Where is my
They
system?
did not read your profile.
They
They did not read your profile.
You know,
So I need to discuss that level of communication that you can give all your best to what you are doing. And somebody sends you a very brutal review. There's a review that says, I will report you to your VC.
you know, it's not joke.
I had to give him a very serious reply. I apologize.
That's a good one.
So we need to keep that in mind so that research communication can be quite.
So when you were talking, something ran through my mind. And what ran through my mind was, by the time you're done with this kind of beautiful paper, that's why I think, I don't know if it was him I shared that with, that I've made up my mind that I'm not publishing for promotion, right? Now, and you send this kind of work, maybe the professors assessing it and the students person, because most of them are not, their minds are not ready to transition, right? So assuming you do this and you're assuming that, okay, this is what you've got. So for me, even before this time, my mind is, I don't want to be limited with my uniform. So I want to move beyond. So it aligns with the thoughts being shared. So technically, I don't know for that. Me, I'm prepared, but how go with that kind of rejection? Yeah, certainly there will always be hurt, but bounce and go.
So how do you manage when somebody says that this thing you have done, I will report it to your VC?
That's a difficult one, but like you respond. But there's a second thing. This morning, I was going through. I went through Google Scholar. I went through Google Scholar checking, for instance, Professor Nathan who taught this, and I could see that I was looking out for some of those journals where they had looked at some of the work that in this line. So I think the best way also you look out for papers. There are people like you have already said, but you not send this work to one guy that maybe wants expecting expecting those stuff. Obviously, that's very no, you do.
Yeah, it's a blind review.
But even as much as it's blind, if you if the journal deals with some computational stuff, that also takes you out from some of that's where I'm coming from.
Okay, today we can share this. Is we have
Me, document.
this is a code number.
Yeah.
Please share that.
But only if you clean out.
Okay.
But if you can send me the link, I can.
It's
Oh,
my
that's
the
the
final
main
thing.
because of promotion, I'm not done.
Is our universities doing scopes for promotion yet? We're still far away from them.
No, sir, not far.
My university,
For me to get to
they
SN,
require-
I have to submit 3 contributors.
Yes, they require.
Yeah, then once it's finished, but not for now. They should
But
just like
so for you, it's been there since now.
it has been there.
It's,
Even
If
lecturers,
you know, PhD students for which
yes, it's us down south.
mean the point
people are enjoying.
Yeah, what? Yes, down south.
and Nasara.
Yeah.
I think that Nasara have the Nasara people are to complete for you.
I love this.
You just join here. You send it to me.
So this year, I stop the
While we get to this, while this is coming up, how we can do all of this with AI. Now, like I said before, that when AI was not here, we usually depend on our professors to tell us what is current, what is novel, and what's original. We have moved from that now because AI is now here, and we can now do all of that. So when you have your data, it is many. How can you find the pattern in the data? If it depends on your ability, it will take a while, it will take 1 week to find the pattern there. Know the data. Pattern in the data. So load the data into Cloud or ChatGPT. The first question I ask is, do you understand this data? That is the prompt. Do you understand this data? So what it did, the next prompt will be summarize the pattern in this data. 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 Prompt number 3. From the pattern, what are the possible research problems? What are the possible research problems? What are the possible research problems that can be framed? What are the possible research problems that can be framed? Prompt number 3 or 4. Suggest research topics. Suggest research topics in the method, problem, solution, application framework. Suggest research topics in the method, problem, solution, application framework. Remember, I mentioned that topics for computational research follows the MSAC framework. There are plenty topic framework. MSAC is one that can allow your paper to get published readily and easily. So once it gives you the topic, you will now take the topic to, you cross the models. If this thing you did in ChatGPT, you have done the same thing in cloud simultaneously. Now, when it suggests a topic, you cross the topics. The topic that cloud gave you, bring it to ChatGPT for assessment. The topic that ChatGPT gave you, take it to cloud for assessment. If you ask ChatGPT to assess the topic it gave you, you tell the topic is correct. even if we had PT. 4 things. Assess this topic for NOC, for novelty, originality, currency, and specificity. Assess this topic for novelty, originality, currency, and specificity. Yes, topic as specific. If any of them gives you 7.5, you're good to go. While you're still there, tell me to give you literatures that support the problem within the topic. If any of you is in health, we use FICO framework. FICO framework, PICO. Population intervention, comparison and outcome. FICO, population intervention, comparison and outcomes. I know in practical research classes, it was taught as a principle for objectives. No, it's a topic framework. FICO, PICO. There's also population exposure outcome. That's a topic framework for people in health sciences, public health, population exposure outcomes. So that is how you can use AI model to find the topic. You could also put your whole data in those models to turn into visuals for you. Yes, they can turn into visuals. Just that how you prompt 2 of them will be different. Part is written in Julia. Julia is a programming language. ChatGPT is written in Python. So if you want to prompt Python, ChatGPT to turn your big data to possible visuals for you, this is the prompt set you would use for ChatGPT. Write and execute a Python code. Write and execute a Python code. Write and execute a Python code that uses my problem statements. That use my problem statements. That use my problem statements to generate plots. To generate plots that meet or fulfills the thesis statement. Optimize the plot for research purposes. Optimize the plot for research purposes. Optimize the plot for research purposes. Use bold fonts for the title and axis label. Use bold fonts for the axis and title labels. Use the red, blue, orange, black color theme and title labels. Use red, blue, orange, black color theme. For the plot lines.
Hello, Doc.
Yes, sir.
Doc, we are not heard along.
On which part of this prompt?
In fact, from the time you started talking without slides, you know, we just get parts and then the part will not get. Sometimes when we see your face, we can read from your lips what you're saying.
This is not part of the slide.
Okay, the slide stopped moving and then
So
we,
this is not part
we
of the
can't
slide.
see. Okay.
Can you stand and look at this?
Now, was this recorded? I think this is recorded. This will be shared after now. I'm just giving you prompt tips to AI models that can aid with your computational research. I know that some of us are afraid of AI and we don't even know what AI can be used for and cannot be used for. I am telling you that AI can be used for data analysis and give you visualization. And these are the prompts and how you can use them. And it is ethical to do. It is ethical to use AI to generate your plots. It is ethical to use AI to find trends in your data. It is even ethical to use AI to tell what plot you should make. Some of us stay long in our research because we don't know what plot to exactly make. AI can tell you for this your research question, this is the plot you should make, and that is ethical to do. The gist about AI is whatever was grunt work can be given to AI. Whatsoever is grunt work in research can be given to AI. Yesterday I shared something online. Someone was saying, no, this is I said, no. You know what's grunt work? Any part of research that does not tax your mind is not research. Any part of research that does not tax your mind is not research. Searching for literature is not research. You can pay somebody to do it for you, but those people to do it for us.
Hello, sir.
Yes.
Yes, there was something you said. There was a statement you made just now. I didn't get it.
I said,
Can you please repeat
grunt
yourself?
work. Any part of research that is grunt work, G-R-U-N-T.
Okay, grunt work.
Yes, can be subletted source to AI, and it's ethical to do in research. And I'll give you some grunt work that we have been doing from time immemorial that is not research. Searching for literature is not research. If it's someone I want to school can do that for you. Yes. Searching for literature to support your work is not research. I can pay the computer boy center in my campus, so please find me all the papers that have discussed COVID-19. Arrange it for me and send to me. It's not research. So that is grunt work, can give it to AI. You have gone to the field before and came back with data. I'm aware I'm going to give it to the computer boys to do it for us. Please take the data, do some analysis for me and all of that. It is grunt work, it is not research. So converting data to what's it called? To visuals or statistical analysis is not, it's not research, it's grunt work. AI can be supplemented to AI. What is now research? What is the part of research that troubles the researcher's mind, that needs you to know research to do? Finding topic is not grunt work, it's a researcher's business.
Yeah.
Finding a topic that is novel, current, original, specific, researcher's business. Even when you give it to AI, tell me that this one is correct, but it's not correct. It will need to tell AI, no, this topic is not correct. You not tell you, oh, sorry, I made a mistake. This is not what it's called. But if you don't know what, remember that, please, let's note this, that AI models are amplifiers, not intelligence. Yeah. There's going to be smartness and intelligence. It is answering artificial intelligence is only smart, not intelligent. It awaits your intelligence to be intelligent. So if you're not intelligent and you get to AI model, it will mess you up. I made a post on Monday, and somebody went to AI and copied an AI response to counter the post. I don't know that I said, this. The AI has deceived you. You're not wise. That's why it has deceived you. You didn't even know that they're telling you something wrong. So it is not an intelligent, it's a smart machine, not an intelligent machine. That's one. Two, AI is built on probability, vector probability. The mathematics, you know what I'm talking about. It's built on vector probability. So what one reply is giving to you is taking from the next available word to do to more with it, present it to you.
Excuse
So
me, sir. I don't understand your last sentence.
I said that AI is built on probability.
You said it's not a smart, is a smart machine, but not an intelligent one.
Yes, it depends on your intelligence to be intelligent. It depends on your intelligence to be intelligent. And it is an amplifier, meaning that if you go to AI and ask a foolish question, it will give you a foolish answer and convince you that the foolish answer is correct. You go to it and say, show me that this PhD topic is correct. Tell you it's not correct. This topic is very correct. This is why it is correct. And you carry that much correct that AI says this topic is correct.
Yeah. Yeah. So I would like to give an instance, like in my department, I'm in charge of projects. So a graphic designer designed the cover of our departmental handbook and gave it to my HOD. Maybe he didn't check it. And when he got to me, behind it there was this diagram of software engineering development cell. The moment I looked at it, no, this is rubbish. You give this to the students, they will think this is the model. They can even take it to the exam or and start writing. You just be wondering why they fail. Why? Because the graphic designer depend on the AI to design for him, and he gave him rubbish. So you must know the content
Intelligent
for you to review AI.
for AI to give you the best.
Yes.
If you go to AI now to give you a research topic, it will give you a wrong research topic. It is waiting for you as a researcher to tell you that this topic is not correct. Write this topic for me in MSA framework. Use these rules of topic formation because, of course, research topics have a rule of formation. I see that a lot that people say there's no general rule for forming topic. No, there is a general rule for forming research topics for publication and for thesis. What's it called? Thesis. For one, a thesis should not claim the solution in the topic. A topic said strengthening parliamentary oversight. Strengthening, you mean that your research will strengthen parliamentary oversight? No, it's not possible. You cannot. Your business of research is to ask questions and ask puzzles. Not telling us that your research will be used to strengthen parliamentary oversight of the executive. No, it cannot happen. We have abstracted what research can do, and I guess it got it from AI. So, research topic has rules, and for Scopus publication, there are plenty rules of research topic. I'm not sure we'll discuss all of them today. Maybe I'll share you one or two videos, some of my videos on how to formulate a research topic for a paper on Scopus.
Well, are there such documentation?
Yes. I recently created an online library that has 5,000 books to tell you everything about research. You can access it for free.
Yeah.
It's on Telegram. I think I don't know if you have a link. Please share the link. So I currently have 5,000 books.
You know where to drop the information.
So if all of these gist I'm talking, there are books on research, plenty books on PhD, on master's dissertation. It's not that somehow didn't get to us, but there are books. There is a book called Authoring a PhD, for example. It's a book from the 80s that tells you the principle of how PhD became a thing and laid down the principles of writing a PhD thesis. So we'll get to all of that. That's the few I wanted to talk. Before I leave, I did. Okay, for cloud, you would say write and execute a GDR code. The difference between ChatGPT and Clouded uses Julia. It's a Julia program.
I don't think.
Okay, the same story, but
Yes.
I don't think.
So do we
that
have-
also give it Python program.
It's an Python program. It can.
So you want
But it's original
to
program.
take it perfect and generation Julia.
Yes, and convert it to Python.
Because many computer scientists said I know yes to speak to Julia. His big name is still Python.
It writes a Julia code and converts it to Python. That's the beauty of cloud. And Julia is a lot more advanced than Python programming. Okay, question and answer time. Before I leave, the introduction section for a paper that will go to Scopus follows the problem gap solution framework. This was down somewhere. The introduction part, the introduction section of the paper for Scopus Index Journal in any field, and especially in your field, follows the problem gaps solution framework, PGS. In paragraph 1, you discuss the problem using a hook and inverted funnel. In paragraph 1, that is your introduction will be of 3 paragraphs. The first paragraph is the problem paragraph. The second paragraph is the gaps paragraph. And the third paragraph is the solution paragraph. Problem begins with a hook, a global scale hook. A global scale hook, and narrows down to the specific problem using the funnel framework. Narrows down to the specific problem using the funnel framework. The gap paragraph synthesizes previous attempts to solve the problem. The gap paragraph synthesizes previous attempts to solve the problem, the successes and failures. The successes and failures, and close with the gap statement. Remember that somewhere there you have produced the gap statement. I said that the gap paragraph synthesizes previous attempts to solve the problem. Synthesizes previous attempts to solve the problem. There are successes and failure, and the critical gap that remains. The critical gap that remains is your gap statement. The solution paragraphs open with the thesis statement. The solution paragraph opens with the thesis statement. That's where you write such things like, this study fills this gap by doing X, Y, Z. The solution paragraph opens with the thesis statement. Progresses to the method direction. Progresses to the method direction. Progresses to what has motivated this method direction. This method direction is motivated by XYZ study or by that. The method direction. And closes with the novelty statement. And closes with the novelty statement. There's so much we can do for today, but let's keep it there.